Welcome to the Explainer. Today, we're going to pull back the curtain on how software actually works. We're going to give a computer program a brain, basically teaching it the fundamental skills it needs to make decisions, repeat actions, and even understand language. Okay, let's dive in.
So you ever wonder how a program actually thinks? I mean, it can feel like magic, right? But it's not. It's really all about giving the code a set of rules and tools to follow. And today, that's exactly what we're going to do. We're going to build that thinking process piece by piece.
So here's our game plan. First up, we'll teach our code how to make smart decisions. Then we'll get into automating repetitive tasks. After that, we'll get it working with words. And finally, we'll pull it all together and see how it fits into the programmer's toolkit.
All right, first up, making decisions. This is probably the most basic, most essential skill we can give our code. It's the ability to choose. This is what turns a dumb list of commands into a program that can actually react and adapt to things.
And the tool we use for this is called a conditional statement. The easiest way to think about it is like a simple rule. If you see this one thing, then you do this specific action. Seriously, this simple idea is the foundation of pretty much all logic in software, from checking a password to deciding if a player in a game has leveled up.
And programmers have a few different ways to build these rules. You've got your basic if statement, then there's if-else for when you have two clear options. You've got the else-if ladder for checking a whole bunch of different things in a row, and the switch statement, which is great for picking one option from a clean list of possibilities.
Let's look at the simplest one, the if statement. The logic here is just beautifully direct. We've got a variable, score, and we set it to 85. The program then asks one simple question. Is that score greater than or equal to 60? Yep, it is. So it prints out, student passed the quiz. Just like that, we've taught it how to make a judgment.
But wait, what happens if the condition is false? With the simple if statement, the answer is, well, nothing. The program just skips that block of code and moves on. That's where if-else is so useful. It gives the program a plan B. It creates two clear paths, one for true and a default path for everything else.
And here's a perfect real-world example. A website needs to check, is this user an admin? If the answer is yes, it sends them to the admin dashboard. But if the answer is anything else, they get sent to the regular student dashboard. This super simple either-or logic is running behind the scenes on tons of websites you use every single day.
Okay, so our program can make a decision. That's great. But what if it needs to do something over and over and over again? Are we really going to write the same line of code 1,000 times? No way. That would be a nightmare. And that's exactly where loops come in.
A loop is basically a program's secret weapon for being efficient. It's a structure that lets you run a block of code again and again until some specific condition is met. This saves an unbelievable amount of time, it cuts way down on human error, and it's absolutely essential for tasks like, say, processing every single item in an online shopping cart.
And just like with conditionals, we've got different kinds of loops for different jobs. The for loop is your best friend when you know exactly how many times you need to do something. The while loop is great when you just need to keep going as long as some condition is true. The do while loop is similar, but it guarantees the code runs at least once. And the for each loop is a super handy shortcut for going through every item in a collection.
Here's that classic for loop. It's built for when you know the exact number of repetitions. See how it works? It does three things all in one line. It starts a counter I at 0, it sets the rule to keep running as long as I is less than 5, and it adds one to I after each time it runs. The result, a perfect predictable count from 0 to 4.
Now, the difference between a while and a do-while loop, it's all about timing. A while loop is cautious. It checks the condition before it does anything. So if the condition is false right from the start, the code inside never ever runs. A do-while loop, though, is more of a do first, ask questions later kind of loop. It runs the code once, and only then does it check the condition to see if it should go again. That guarantee that it runs at least one time is actually a really critical feature in some situations.
Okay, so our program can choose, and it can repeat. Now it's time for its final core skill. We need to teach it how to understand and work with text. This is how we get software to actually communicate with us humans in a way we can understand.
In the world of programming, any piece of text is called a string. It's really just a sequence of characters. But don't let that simple definition fool you. Strings are how programs handle literally everything, from a person's name to an error message to the entire text of a web page. They're absolutely fundamental to the user experience.
Now listen up, because this is a big one. This trips up almost every single person when they're starting out. To see if two strings are the same, your first instinct might be to use the double equals sign, but you almost never want to do that. The double equals operator checks if they're the exact same object in the computer's memory. What you almost always want to know is if they have the same actual letters inside them, and for that, you have to use the dot equals method. It's a super important distinction.
All right, let's do a quick little brain teaser. We create a string variable, we'll call it S, and it holds the word Java. Simple enough. Then we run this command that really looks like it should add rocks to the end of it. So think about it for a second. After this line of code runs, what do you think is inside our S variable?
And the answer is just Java. It didn't change at all. What gives? Well, it's because strings in Java are immutable, which is just a fancy way of saying they can't be changed. When you do something like concat, it doesn't actually modify the original string. Instead, it creates a brand new string in memory with the result. It's a really important safety feature of the language.
The good news is, even though you can't change strings, they come with this whole built-in toolbox of methods to help you work with them. You can easily find out the length, or convert everything to uppercase, or trim off extra spaces from the ends. You can even replace words or split a whole sentence into a list of individual words. These tools make handling text way easier.
So, let's bring it all home. We've just put together the fundamental toolkit that pretty much every single programmer uses every single day to build all the software that we use.
So what does our program's brain look like now? Well, we gave it conditionals so it can make choices. We give it loops so it can handle repetitive work without getting bored or making mistakes. And we showed it how to use strings to work with text and communicate with us. These three things, they are the absolute core building blocks for solving almost any problem with code.
So we've seen how code can decide, how it can repeat, and how it can communicate. And these aren't just some abstract technical concepts. They are literally the building blocks of creation in the digital world. They're the tools you use to solve a problem, or to create art, or to build a business. So the only real question left is, what problem are you going to teach a computer to solve first?